courthouse.
Yeah. Not that fancy. All right. We are looking at 93, and we're talking about spheres, pyramids, and cones. This isn't going to be any different. We have our formula, so it's going to be helpful. So volume of a sphere, you have your formula on your volume sheet, which is right here. I don't expect you to know it, but I expect you to be able to use it. So volume of a sphere is 4/3 pi, but it's r to the third. So pay attention to that. If you look at surface area of a sphere, it's 4 pi r squared. So pi r squared is the area of a circle. 4 times it gives you your sphere. This is for surface area. This is 4/3 pi r to the third. And that's it, guys. We're going to do that exact and approximate again. So they gave me the radius. So here's my formula, 4/3 pi times 4 to the third. Now, if we want that exact answer, you're going to leave pi out of the calculator. So grab your calculator, which you should have out. Type in 4/3 pi is being skipped. So 4/3 and then times 4 to the third.
Oh yeah, Miss Brian, I found my calculator.
Do you have it out now?
No, it's in my house.
Which one is it for fraction?
What'd you say?
Wait, which one is it for fraction?
For my calculator and yours, it's this one, the ABC. So when I put this in the calculator, this gives me 85 1/3. So I'm going to write that down. 85 1/3, but don't forget your pi. Now, if you're one of those slant writers and you're going to write it as 85, and I'm trying to find another piece of paper here. If you're going to write it as 85 1/3 like that, pi, you need to be careful because it looks like pi is part of your denominator. So that's why I try to write my fraction like that. The other option you have is to tell your calculator second and then your mixed number to improper. You could also write it as 256 pi over 3. I'll take either. Now, whenever you do this, you are then going to label it centimeters cubed because you found volume. All right, how do I get the decimal or the approximate? I'm going to take my answer times pi. And I get 268 point, what's it tell us? Nearest tenth, 268.1. And that would be centimeters cubed. Okay, move on to the next one. They don't give me the radius, they give me the diameter. So what is my radius? Thank you. 8.2. I'm going to write that pretty big so I see it and I don't use the wrong one. Here's my volume formula. 4/3 pi 8.2 to the third. Okay, now I'm asking for the exact. That means you don't put pi in. So 4/3 is a repeating decimal. That's 1.3 repeating, but we know what that is. So we're not rounding it. I guess we are, but if we keep it as a fraction. Times 8.2 to the third. Now, this is probably going to give me a decimal. Do you see it? So it says exact answer. It's not actually an exact answer. It is truly in terms of pi. So I guess if you look at this worksheet, it doesn't say, it says express your answer in terms of pi. This is not an exact answer. If I round this to 735.2 pi, I have rounded it. So notice it doesn't say exact, it just says with pi. And then this would be feet cubed. Now, if I wanted an exact answer, I would take my fraction or my decimal and I make it turn into a fraction. It's a fraction to decimal. And the exact answer is really ugly. Do you see it? 735 and 59 3/75. So you could write that down, but I will take a rounded decimal. We'll know that it's just in terms of pi, not exact. Okay, now, if I go back to my 735.2 times pi, I will get my approximate answer of 2,309.7 feet cubed. Okay, so what if the above examples had only half of a sphere? What would you do? Remember, we're finding volume. How would you find half of the volume of a sphere? You would take the volume and you'd say, hey, I only want half of it, right? So same formula, but we would take half of it. Now, what if the problem only had 1/4 of a sphere? Well, I would take the volume and take what? 1/4 of it. So that's all. Are you with me on that? Keep your formula. I only want half of it. If I only had 1/4 of a sphere, that'd be like taking that chunk out of the top. Then I'd want 1/4 of it. And then we can clean up this formula. All right, fabulous. Flip it on over. Now we're changing modes and we're going to the volume of a pyramid. Now, if you look at your formula sheet, which mine's drawn all over, if you come back up here, we have volume of a prism, which was just base times height. The area of the base times the height of the figure. Area of the base times height of the figure. The volume of a pyramid or a cone is 1/3 the area of the base times height. So if you didn't write this down before, can you add this on your formula sheet? It's 1/3, and the B stands for the area of the base, and the big H stands for height of figure. So you will have a base and a height of the bottom, like if it's a triangle or here. But you also have the height of the figure. And the height of the figure has to be an altitude. So I'm going to add that in there. It's got to be the altitude, not the slant height. But other than that, you're doing the same thing, really doing the same thing we did before. We just need 1/3 of it. All right, are we good on the formula sheet? So here we go. Take your little formula and put it in here. Volume equals 1/3 base times height. I guess I'll use a capital H here. That B stands for area of base, and the H stands for height of figure. Height of figure, and that is the altitude, not slant height. All right. So the big B stands for area base, the big H stands for height of figure. So here we have either a square or a rectangular pyramid. And this is going to be a lot easier than surface area, because in surface area you had to find the area of the base and then all of the sides if they were, different. Here we're just going to do 1/3 of the area of the base and then multiply it by the height. Now see how this has an L here? That's the slant height. We're not using that. We want this height. Okay? We want this height for the figure. This, thank you. That is the slant height. And I think that's why they use, S is used for other things. I think that's why I use the cursive L, because of the L in slant. It's like the second letter. Okay, let's do this. Find the volume of each figure, round to the nearest tenth. So volume is 1/3 area of the base. So what kind of base do I have? I do have a square base. So that would be, I'm just going to say 5 times 5. Area of the base, and what's the height of the figure? 4. Okay. So type this into the calculator. 1/3, 5 times 5 times 4. Now, if it was a prism, it'd be 5 times 5, and the whole thing would go up. But we only have 1/3 of that volume. So 1/3 times, you can use parentheses, not 5 times 5, and then times the height of 4. And I get 33 1/3. So I will take the fraction, 33 1/3. I will take the decimal of 33.3 because it said round to the nearest 10th. Now, if it says round, you don't put the repeating sign on it, and we would label this meters cubed. Okay. Look at the next one. What kind of figure do I have here? Anybody?
Rectangular pyramid?
Yeah, it's a rectangular pyramid. So volume equals 1/3. Area of the base is 12 by 8 times the height, which is 12. Guys, we're doing the same thing we did with rectangular prisms, but we're taking 1/3 of it. If I would box this in, this would only fill up 1/3 of the box. All right, type that in your calculator. 1/3, 12 times 8 times 12. Yeah, I want to make sure I had that right. I have 384 even. Do you agree? All right, and that would be, again, meters cubed. Make sure you're labeling these properly. Look, we took meters times meters, and then times the height of meters. Okay, how about number 5? What kind of figure do we have there? They're all pyramids, right? But this one is a triangular. Now, there's some extra information here. So, it is 1/3 the area of the base times the height. Now, the height of the figure goes from the pyramid point to the base with a 90-degree angle. So we do have the height of what? 6? What is the area of a triangle? The area of a triangle is 1/2 the base of a triangle times the height. Now, look at your triangle. Do you see it here? I'm going to use 3 as my base. What would be my height? The 4. Do you see the right angle in the corner? Do you see it now? Okay, so be careful. 5 is that hypotenuse. We really don't need it. So base and height, or height and base, because they're off the 90 degrees. So if I call this my base, it has to be 90 degrees to be the height of the triangle. And then you have the height of the figure. That's the difference. All right, type it in your calculator. So 1/3 times 1/2, or 0.5, times 3 times 4 times 6. I get 12. Yeah. 12 what?
Miles
Cubed. Yep, miles cubed. All right, look at the next one. What is this one? Square pyramid. Okay, so volume equals 1/3 the area of the base, which is 64 from the 8 times 8. And here's my problem. A lot of us are going to put 9.8 as the height. What is that? That's the slant height. So make a note of that. Slant height. What do I want? I want the altitude that's going to drop in the middle. Now, if you can picture this, draw a little line dropping and connect it. This right here is a cross section. So here's where it drops in the middle of the pyramid and it goes to the side. Okay, this is 9.8. This is the side of it. What would this be from here to the middle? That would be 4. Do we see that? So when I need the actual height, that's when I'm going to use Pythagorean theorem. Otherwise, I don't use it. So guys, the height, this would be 4 squared plus h squared, be careful with that, equals 9.8 squared. That's the only time I have to use Pythagorean theorem. I've got that as 16, but I don't know what 9.8 squared is. Mr. Adams probably knows because he's amazing. If you probably did that in your head.
I did. I had it down.
I just didn't want to take the time, Mr. Adams. Minus 16 from both sides. So h squared equals what? 80.04. All right, so I've got that in my calculator. I'm going to take the square root of my answer because I typed it in there. And I get about 8.9. That's what I'm going to round it to. If we want to be more precise, we can keep a couple more decimals. Okay, so that is the height times 8.9. So I had to do a little extra work to find it. All right, type it in. 1/3 times 8 times 8 times our 8.9. Again, if you wanted to be more exact, you could keep a couple more decimal places. I got 189.9. 189.9 what? Inches and cubed, because we're finding volume. All right, fabulous. Last part. Jump to cones. Now, you are going to see that we are going to use the same premise of the formula. The volume is 1/3 area of base times height, but a cone will always have a circular base, right? So what formula would we use? 1/3 pi r squared h. I don't need the parentheses, but I'm trying to show you this is the area of the base. Now, when we did pyramids, we had to look and say, oh, it's a rectangle, it's a square, it's a triangle. I don't think you have that specific formula on your formula sheet, so let's add it. Do you see that it is the same pyramids of cones, or volume of the pyramids in cones? But let's get a little bit more detailed. So let's draw a little cone down here. So volume of cone, that way it's all in one place. Here's my cone. Oh my, can you guys do a better job than me? Oh, well, mine's looking a little, you know, we'll try to save it here. There's my cone, there's my radius. And remember, we want the height, that 90 degrees, even if it's like dropped down outside. And so the volume of a cone is 1/3 area of the base times the height of the figure. I'm a little embarrassed for myself. So it is the same for the formula of a pyramid, but just instead of putting base here, we're going to be a little more specific. Okay, I'm going to take that embarrassment away and act like it never happened. All right, look what we have here, guys. Volume equals 1/3, that's staying constant. The area of the base is pi r squared times the height of the figure. Okay, so I got 1/3 times pi. What's the radius of this guy? 2. Yeah, be careful with that. Radius is 2 times the height. We have an altitude of 4. All right. Type it in the calculator without pi. Now we're going to get some decimals probably. Okay, so not an exact answer, but keep pi out of it. 2 squared times 4. I got 5 1/3. So I'm going to write this as 5 1/3 pi centimeters cubed. You could also have it as 16 thirds pi if you have the mixed number or improper. All right, what's the decimal, guys? Take your answer times pi. I agree. 16.8 centimeters cubed. Okay, now look at the next one. Volume equals 1/3 pi r squared h. Fabulous. 1/3 pi, what's the radius? 5 squared. What's the height? That you don't know. What'd they give you? They gave me the slant height. So this is one where I have to do a little extra work. I'm going to have my height. They even gave you a hint in here. I have my height squared plus what? 5 squared equals 13 squared. I can't stress this enough. It's the leg squared plus the leg squared off the 90 degrees, and the hypotenuse is what it equals. So you have to be careful with that. All right, so that's 25, and that's 169. All right, subtract 25. What do we get? 144?
Yeah.
All right, so what does h equal? 12. And that's reasonable. Your height should always be less than your slant height because the hypotenuse is the longest. So here we go, times 12. Type that in the calculator without pi. 5 squared times 12. Ooh, 100. Fabulous. 100 pi centimeters cubed. Okay, so if we take 100 times pi, aren't we just shifting the decimal? 314 point what? 0.2. Yep, you're right. Centimeters cubed. That's it. We're donezo.